All right, so thanks to everybody who showed up today. I know you guys have a choice in how you spend your time, and I'm really appreciative of the fact that you're here. So can everybody hear me okay at this point? Please just go ahead and put in the chat or raise your hand if you cannot. Okay, I'm getting so many yeses. That's great. Okay, awesome. All right, so my name is Dr. Bidushi Bhattacharya, and I know some of you, and I know some of you have also sent me email because you all are very interested in space. And in this new post-COVID world, what I'm really trying to do is to get you guys to think about new career options and new pathways that you can take to make the world a better place. I'm in Southern California at the moment. You know, I go back and forth a lot between here and Singapore. But in Singapore right now, there's the circuit breaker, and then here in California, they're also slowly starting to open up, but we've kind of been in the same place, just stuck here at the same time. So the best way to spread the word typically for us has been in person through workshops. But at this point, we all have to just resort to two-dimensional images. And I know that's nowhere near as satisfying as seeing each other face to face. And for me, it's a little bit challenging too, because I'm not getting group energy usually when I'm on stage or in front of everybody. I can just kind of sense whether people are engaged and whether they're getting what I'm saying or not. So because we have this sort of two-dimensional limitation here, I do encourage you to type into the chat if you have any questions. And at the end, we will do a Q&A. And if there's anything that comes up urgently, go ahead and raise your hand and I will see if I can see it. I should be able to. But anyway, so for those of you who are not aware, astropreneurship is entrepreneurship in the space sector. We all know about SpaceX. You just saw the video of Elon and NASA's rocket. You saw them going into space. That was on May 30th, just a couple of weeks ago, actually. And they put a couple astronauts onto the International Space Station. And I know people normally ask me, why are we spending billions of dollars taking people to space? Why is it worth it? We've got lots of crises here on Earth. But the thing that I really want to emphasize is there's nothing as inspiring as going to outer space. And in terms of the benefits to us here on Earth, there are numerous technical inventions. We'll mention a couple later. But there is a need to push people, right? And if you get people to work on space tech, you tell them they have to get something ready, hardware or software for an astronaut, what you can see is really an accelerated rate of growth. So space, I think, is unique not only because it's beautiful and people are interested in it, but it really inspires people to move forward and just innovate in a way that they would not do otherwise. So let's see here. Okay, so this image that I had on the cover slide, let me just mention it to you briefly. This is one of my favorite images from space. What you see right here is the Canadian space arm, and above this is the International Space Station. We'll show you an image of the whole thing in a little bit. But down here, this is the surface of the Earth. And this little rainbow bit here is the Earth's atmosphere. And then you can see stars in the background there. And this streak right here is the SpaceX Dragon back in 2017, bringing back cargo from the International Space Station. It was released from this point here, and it flew back down to Earth and landed in the ocean. And one of the things that it had on board was a set of our student experiments. So you can actually see that they're going through re-entry in the atmosphere, and you can see the burn trail here as the Dragon is coming back. And so the students actually that very first year were looking at bacteria in space. And we'll get into that in a little bit. But I think the really interesting thing here, the takeaway message, other than the fact that this is a beautiful image, is that space has become so accessible that at this point, even students, high school kids, have access to it. So why am I doing this? Let me tell you a little bit about myself for those of you who don't know me already. My name is Bidushi, and I have worked for 30 years for NASA and the commercial space sector. I primarily for NASA worked on spacecraft calibration and mission planning, and I've also done a lot of public speaking and worked as a media consultant as well. I worked on the Hubble Space Telescope. That was my first job out of college. It was great because I got into the space sector and I also got a husband out of it. My husband and I met in the computer lab on the Hubble. It was very nerdy. But I worked there for a few years on the East Coast of the US on the Johns Hopkins University campus, and then moved to NASA JPL, Jet Propulsion Laboratory in Southern California. And I'm now CEO and founder of Astropreneurs Hub. So this is a picture of me live commentating the moon landing for the BBC for the Indian Space Agency last year. For those of you who are not familiar with it, the lander came very close and then actually crash landed. And it was probably the most awkward live interview I've had in my life, because I could actually see the graph of the altitude and it had just taken a dive, right? And I knew what had happened, and I didn't want to say anything before they actually announced it there, but you could hear people whispering in Modi's ear, and I was just, it was a fun event, but it was actually very stressful too. So I've also given talks at things like Women's Forum in Asia and done TEDx talks as well. So let me show you this picture. This goes way back. This was taken in 1990, just a few weeks before the Hubble launched. This was on the Hopkins campus, the Space Telescope Science Institute where I worked. And you can see me, one of the few brown faces. There you go. And this guy here is Dr. Riccardo Giacconi. He went on to win the Nobel Prize after this. So I was really privileged to work with a very prominent group of people. He was actually our director at the time. And we've had a lot of really smart people working on this project who've done major things for the fields of astronomy and also for space tech in the 30 years since I started working out there. So let me just quickly give you a sense of what I think your learning objectives for today should be. I mean, why are you here? Why did you sign up? Let me tell you what my goals are. I'm hoping that you understand why the commercial space sector, NewSpace, actually needs you by the end of the presentation. I'd like you to understand the difference between big space and what I just defined as the commercial sector, NewSpace. I'd like you to look at potential growth markets in the post-COVID-19 global economy. We've had such a game changer in so many ways, everything from not being able to get the groceries we need and not being able to go out to having people have real economic challenges just all over the planet. So there will be new services that will be required. And I'll give you some examples of some areas where space is uniquely poised to lend a hand. I'm also going to give you a list of online resources that can help you further study new space companies. Now, my goal is to have you walk away from this presentation and go talk to your colleagues, talk to your friends, and think about what it is in space that you want to learn more about, with the goal being that you join us in our workforce in whatever capacity with whatever talents that you have. I'll emphasize this again later, but we are now moving from an era where you do demonstration of tech in space to an era where we actually have consumer services, right? We're in an era where we actually want people to derive new technologies to make life better here on planet Earth. So what I'm going to do, oh yes, and I want you to understand that rocket science is not mysterious. Let me run our first poll here. So there should be a poll up on your screen at this point. We're asking, where are you currently based? And let's see what people say. We'll have some people tap in here. I'm going to give it about a minute, and then I will share the results with you guys. All right, looks like so far Asia is in the lead. So much depends on the time of day that we hold these, right? That's one of the challenges of global business. We, on a regular basis, have to shift around the times of our presentations just to ensure that people actually can attend from different time zones. I don't think we'll get anybody from Europe in particular for this time zone, because that would be here. Oh, so it's 5 a.m. in Kenya. Thank you for showing up, Ian. That's cool. I admire your commitment showing up this early. Okay, it's been a minute. Let me end the poll and share the results with you. So what you can see is the primary representation here happens to be from Asia, which is not surprising because we established our business there first, but we do have people from Africa and North America on as well. This is really cool because, one of the things I really do want to do is have you guys develop relationships with each other as a global community. So I really like to see as many people from as many countries and continents, actually, how we do it as we can. We had some people from South America and Europe last time, but I guess they must be resting right now. All right, let me just put that poll aside for a minute. Does anybody have any questions before I proceed? Okay. So to just reiterate here, we're talking about knowing the difference between big space and new space, right? So let me define big space for you. Big space is a word that I made up. It's a term I made up. It's space technology that costs billions of dollars. The Hubble Space Telescope is a great example of this. It cost $4 billion to build and launch. They had issues that they had to go back in and fix with it. In spite of having spent $2 billion, they had to spend another $2 billion. And then I also know that the Galileo spacecraft was another multi-billion-dollar spacecraft. It flew from the Earth to Jupiter. It's probably my favorite mission after the Hubble. Hubble was the first one I worked on. I did my PhD after working for NASA for a few years. I went back and got my doctorate, and I used Galileo data studying Jupiter. So Jupiter's always been my favorite planet since I was a little girl. So this spacecraft, though, is another one of these big space examples. So what about NewSpace? The evolution of technology to date has really enabled us to come into this commercial space sector that's known as NewSpace. And how is that possible? If you see here on the left, you've got this Apple computer that was worth $54,500 in today's dollars, right? That's US dollars. And it wasn't really all that powerful. Your phone is 150 times faster today. It has 200 times more memory at least. And you can get an iPhone for about $800. And if you want to go something that's not Apple, you can go for, significantly less than that. So you get something that's smaller and lighter and a lot more affordable. Now, how does that apply to space? Just as you have new software and you have new hardware in space technology and on cell phones, you can actually translate that to satellites. So what I'm holding here is one of our cube satellites. I think I've got one right here, actually. I don't know if anybody's watching, but in my hand, I have actually the CubeSat that you see there on the screen. This is an actual size model. It's a desktop model, not a flight model, of something known as a cube satellite. These things are incredibly light. They're an industry standard. This one has a camera on board, and we use this in our workshops that we teach in person. Obviously, we're not doing that now because we're doing these Zoom webinars, but these CubeSats are an amazingly cheap a platform for taking images of the Earth or using them to make local measurements. You can get a CubeSat right now for on the order of $300,000. That is, you can build it and launch it with a very basic instrument set on it. So we're talking 300,000 versus billions of dollars. It's a complete game changer, just like in the IT industry with microprocessors. So since we do have these cube satellites now, we are also moving into a realm of new space technology. And I'm using this particular image because I don't know if you're aware, but astronauts have to go into quarantine for 3 weeks before they fly. And the reason they have to go into quarantine is they don't want to get their fellow astronauts who are up on space stations sick. So they have to make sure that they don't have anything that they can actually give to the people that are up there. So let's talk about disruptive innovation. We talked about phones. Now, here's an interesting thing here. We're talking, look at the horse and carriage. This was the primary mode of transportation for most of human history. We had a global economy built on the horse and buggy sector. There were farms for horses. You had to have groomsmen. You had to have stables. You had to have people build the carriages. And then all of a sudden, we ended up with cars. The cars initially that people had were noisy, they were smelly, they gave off sparks, and people could not have imagined them taking over. But in the same way today, we can't imagine a horse and buggy, right? It's something that you might do in a park on a vacation for novelty, but there's no way for us to imagine our lives today without an automobile. And this transition happened very quickly within about 20 years. So now we go to the Tesla, one of my favorite cars. And based on the kind of innovations that we have today, not only do we have the Tesla, we also have SpaceX going up to the International Space Station. So this is the first image of the International Space Station that I'm going to show you today. So the disruption that we got from the car, from the horse and carriage to the car, is comparable to the disruption that we've had in transportation now from the electric car to going into outer space. So what is actually the future of space technology? You might wonder, what are we going to do in this era where we have COVID? It's a real game changer, right? And a lot of people are concerned that the tech sector is going to suffer significantly. But based on my studies of the sector and just looking at job boards, for example, and talking to people who've also been in this field for a while, it's pretty clear that there are going to be new needs that come up where we're going to have to supply solutions super quickly. So one example of that would be global food insecurity. You can see these people waiting in some rather miserable weather to get groceries with masks on. I'm not exactly sure where this is, but it looks like a pretty unpleasant experience being allowed into a store. So we're not sure where we're going with this. Does anybody, okay, so somebody's asking what's the big difference between a CubeSat and a CanSat? I can just answer that very quickly. A CanSat is a satellite that is shaped like a can of soda, and a CubeSat is a small satellite that's a 10 by 10 by 10 centimeter satellite. That's an industry standard. They basically serve the same purpose. They're miniaturized. The CanSats tend to be more for student use, and the CubeSats can be more for commercial use, because you can take one of those cubes and you can stack 1, 2, 3, or you can make a square box of them. You can build out to add more sophistication and instrumentation to those if you want. Okay, so I hope that answered your question. Let me tell you a little bit about us, what we do and what we are motivated to do. So we specialize in the democratization, spelled with a Z here because I'm in California at the moment, not with an S. Sorry, Asia. What we do is specialize in the democratization of space and technology services. We started in Singapore in 2016, and we also now have an office in the US. And we have hundreds of global customers for the various services that we provide. Our team has a combined 45 years of experience with small satellite development, spacecraft operations, and astrophysics. The majority of that obviously comes from me. I've been in it for 30 years, but the rest of the team that we have actually has experience working on spacecraft. So our team members that run our master classes, if any of you have attended those, you know this, everybody who works on our team actually has gotten some real hands-on experience working on spacecraft. So we're not bringing information to you as people from other sectors. We're all engineers and scientists who know what we're doing, and we have a feel for the sector already. So what we're doing is specializing in the democratization of space and technology and services. And why are we doing this? We're doing this because we want to build a global ecosystem, and it requires diverse skills. This is something we mentioned earlier. We're going from an era of just proof of technology to actually building out a whole economy. And that's part of the reason that we're actually running these online workshops. So we want you to be part of a global space knowledgeable workforce there. So here's one of our engineers talking at the Art Science Museum where we were doing a CubeSat workshop. And then this is in Australia. We taught at the International Space University. And the other thing we like to do is, here I am at the NASA Space Apps Challenge in 24. This is an annual competition. It's a hackathon that is run by NASA, and anybody from any part of the world can join. And so this year it's coming up in October. So definitely let me know if you're interested in that. And if you want to know more about our CubeSat workshops, we can certainly talk about that. We hope to be able to open those up once people can get together in a group setting as well. So not only do we democratize access through our workshops, here you can see a video of a couple people working with the satellite that I showed you earlier. And what this guy's trying to do here is he's got it plugged into his own laptop, and he's issued some commands. And he's trying to pop off what's supposed to be a magnet here with a solar panel. And if you watch long enough, you'll see his code does actually have it pop off. And then he gets very excited. Okay, anyway, so this is another one of our courses. And then here we are again at Art Science Museum. So we not only do these CubeSat workshops, but we launch experiments to the International Space Station, and the space station is our theme for today. So we've launched 7 experiments to date to the space station. And this is an image of what the ISS looks like. You've got different modules on station that have been built by not only the Americans, but the Russians, the Europeans, and the Japanese. And then we have that Canadian space arm that I was talking about as well. So in space, there's no such thing as up or down. This does have a belly cam on it. If you want to go online and look, they take some really cool pictures of the Earth as they fly over it. The satellite sits at about 400 kilometers, 250 miles, 200 some miles above the surface of the Earth, and it goes around the Earth every 90 minutes. So what that's really cool for is you can take images of the Earth on a fairly constant basis. And being up at that altitude, taking these large range pictures is something that CubeSats are also very good at. We're now in an era where not only do we get live video feed from the space station, but we are imaging every point on the Earth every day with some of these CubeSats. And that has huge economic implications in areas such as disaster relief, or even in retail. It's very helpful to be able to look at the Earth from overhead for all kinds of things. So the space station experiment, we really want to make sure that the students that work with us have actual deliverables for space. They have a unique advantage, these kids do. They're high school students and university students. They have definite advantage over their competition in STEM. And this particular group that we work with is between 15 and 22 years of age, and we have them build a science experiment for delivery into the hands of astronauts in space. I mean, this is just so cool that we can actually just do this. I would have given anything to be able to do this when I was that age, but you know, for them, it's something that is fairly, I don't want to say commonplace, but there are on the order of a few hundreds of experiments that students have actually run on the space station already. And in the process of running these experiments, in the process of developing them, students actually get to understand NASA design and development methodology. And this will apply to the space sector anywhere. It's not just that they have to work for NASA to, you know, that is relevant to NASA. For any space agency or any space company, there are certain standard steps that you have to take to send stuff into space. And so our workshops, we have workshops in California, and we do have NASA experts who are in part of this program here who provide guidelines on safety, because you are sending something to the space station, which is a lab. It's a laboratory where astronauts live and run experiments all the time. So anything you send up has to be, you know, really carefully studied to make sure that it's safe for the astronauts. So here's some of the stuff that we have had sent up so far. We've had students look at radiation versus melanin in bacteria. They've looked at magnetic fluids, which are good for industrial applications. Electroplating in space, another manufacturing one. This is one of the most fun ones. Whoops, don't know what happened there, sorry about that. This one here with the tooth is one of my favorites, because there was a kid that had a younger brother that lost 2 teeth at once. And so they kept one on the ground for control, and they sent the other one up to space to see what the rates of bacterial growth would be on both the teeth. One of the things that scientists don't fully understand is bacteria just thrive in space very well. There are certain strains that will just, you know, proliferate in space, whereas here on the ground they just wouldn't, and they're still trying to figure out why. And this has significant implications, not just for the health of the astronauts, but in terms of antibiotic development. If we can figure out what causes these bacteria to thrive, maybe we can figure out how to turn that off. They've also looked at protein crystallization, and I'll give you a great example of that later on when we talk about what the astronauts from SpaceX and NASA took up a couple weeks ago. Plant growth, of course, they do that also, and then look at gut bacteria. And you know, when we talk to the parents about this, of course, the metric for many parents is, where do my kids end up going to university or post-grad after they finish this program? And this is just a random sampling of where some of the students have gone after they have worked on the space station. And you know, it's a game changer for their applications. So this is just a partial list. Okay, so why should you be interested in space? I mean, I'm telling you about all these cool things that kids do, and I'm describing, you know, this is an opportunity for them. Let's talk a little bit about you guys. So what I'm going to do now is I'm going to give you another poll. There should be a poll on your screen that says, how often do you interact with satellites? Never, a few times a day, or hundreds of times a day. I rely heavily on space tech. Looks like about half of you say that you use satellites hundreds of times a day, and 20% of you never use it. Okay, another 5, 4, 3, 2, 1. Let me end the poll. And here are your results. So half of you use space technology hundreds of times a day, you're telling me. Some of you, about a third, say you use it a few times a day. You can do without space technology, satellites. And then some of you say that you never do this, and how would you do it? So the answer to this, the correct answer for everybody here, I'm going to say, is hundreds of times a day because of this. You have location services on your phone that derive their physical location information from GPS satellites. Every app you run, every time you go in and you send out something, some kind of information, there's a GPS satellite overhead. It takes 3 of them at once to triangulate your information. They're constantly emitting beacons. Your phone has software on it to know which satellites you're closest to. And it's constantly, your phone is constantly in connection with outer space in a way that really allows you to know where you are. So if you've ever done a Maps app, Google Maps, for example, sometimes you'll see that your location is like really a big circle on the map. And then that circle will shrink up over time. And what's happening is your software on your phone is acquiring multiple satellites to get a cleaner and cleaner sense of where it is, because it's getting multiple satellites to give it signals so it can do the equations and figure out where you're actually sitting. So that is the answer to that one. So yeah, so space tech is a part of your daily life because of GPS. I hope that that surprised some of you, but after this, you'll be able to go and share this fun fact with your friends and family. You can observe large swaths of Earth from space, which is very important. You can't do the same kind of work with drones or even with airplanes. And space has abundant resources. If any of you have ever taken basic astronomy, you know that our solar system and planets all formed from the same material. So all the material that's here on Earth, all the minerals that we have actually exist on asteroids as well. And you know, we have some mining operations here on Earth that produce really toxic byproducts, right? Really toxic. And what you want to do instead is see if you can get those from asteroids. And this may sound far-fetched, but you know, we already rove around on Mars with rovers. We're already digging around with shovels to understand Martian geology. And asteroids actually don't have any gravity. So any sort of material that formed there is very pristine. It's kind of lying on the surface. On the Earth, we've had billions of years for the crust to just sort of shift. And, you know, we have earthquakes and things slide around. So you have to dig and you have to leach out the gold or whatever other material that you want. But if you were to go to outer space, you could, for instance, get rare materials that are very expensive down here. I don't know, stuff like palladium, molybdenum. There are asteroids that have these in quantities that are worth like trillions of dollars. We can use telescopes to figure out what they're made of, and we know how far away they are. Somebody just has to get up there and get this material. So not only would it meet a lot of our needs for certain materials, we could mine up there without environmental impact on Earth. And just parenthetically, one of the things that I want to tell you that is being done right now on the International Space Station is they are testing bacteria that preferentially eat certain minerals, so that if you were to scatter these onto an asteroid, they would be able to eat the minerals that you don't want and be able to leave behind the stuff that you could actually scoop up. So they're testing these bacteria in microgravity right now to see how they function. Cool stuff. So the other thing in microgravity that we can talk about is pharmaceutical and manufacturing opportunities that have real impact here on Earth. And I'll give you a couple examples of that in a minute. But let's first look at the post-COVID-19 global economy, large-scale data for food security, because we showed that picture earlier. What you see here is images from a company called Planet. They image every spot on the Earth every day. Some of the spots near the poles, they'll image a bit more, but every spot on the Earth, they can take a picture every day. So they can look at crops. And why does it matter if you look at crops from space? What's the benefit there? You can look at the health of crops. You can use instruments to understand whether they're diseased. And you can also understand when the crops will be mature for pickup. Small farmers often have to book trucks, weeks in advance so that they can get their crops carried to market. But especially with climate change, it's very difficult to predict when crops will be ready. And if they had an ability to accurately figure out when their crops will be ready just by data that we beam to their cell phones, that would save them a lot of money, and it would save a lot of waste for humanity, because actually 40% of crops, 40% don't make it to market. So our retail supply chain would significantly benefit from not only crop readiness, but if you're tracking your shipments across the ocean, or if you're tracking them on land somewhere, it would be very easy to understand what needs to go where. And so then also, in terms of natural disasters, wouldn't it be great with all of these wildfires that we have to use an infrared camera to look at a hot spot and just say, oh, this area is hot, it's going to start burning very soon, and get to it as quickly as we can. From space, you can easily detect changes in temperature like that. And the difference of a few hours is huge, as we know. So it would be really great if we could be in space, go ahead and look for fires. We can also look for earthquake victims. Construction sites we can look at. There have been some encroachments on native lands in places like New Zealand, where satellite data has helped the local indigenous populations to identify what's really going on, and then take the construction companies to task because of this infringement. It's not something they could easily have detected from Earth. And then a global space-based internet is something that's up and coming. You may hear about SpaceX launching, hundreds of these satellites recently. The whole point there is to create this global mesh of networks so that you have internet anywhere in the world, whether you're in an urban area or a remote area. So let's do a quick summary of what happened last year in space, and then we can talk about what's happening this year. So the Dragon Demo 1 capsule was sent up last year. This was the predecessor to the one that took the astronauts up on the 30th of May. LightSail is a satellite that worked on solar wind pressure. That was verified. SpaceX worked on its Starhopper and Starship missions. And then the Starlink constellation that we referred to in the earlier slide with the internet providers, they actually started launching last year. And Virgin Galactic, that wants to do space tourism, flew their first test passenger, and they went public. They're the first they're a publicly traded space company, in case anybody wants to buy stock right now. On the government side, China landed on the moon's far side. There was, for the first time, an all-woman spacewalk, and the first female astronaut who's going to spend a year in outer space. Then we had India's Chandrayaan-2 crash landing on the moon. India destroyed a satellite in space, one of its own satellites, and this has happened many times before. We've had the US do this, Russia's done it, China's done it, and now India's done it. And people say they can destroy their own property, and this is where you lawyers come in. Because how do you decide who owns what in space? If I shoot down my own satellite, is it my property and it's just my business? Or does everybody else care? Because in fact, there will be thousands of pieces of space debris flying around at 20,000 kilometers an hour. That can be a real threat to other people. So there's several countries have done this. Israeli spacecraft, the Beresheet lander, also crash landed last year. And NASA marked its 50th anniversary for the Apollo mission and aimed to go back to the moon in 2024. So what about this year? It's been a busy year so far, and we're going to have a very busy next month as well. So we talked about the milestone of the SpaceX Dragon mission going on the 30th of May. This says 13th of July, that actually should be June, sorry. Rocket Lab, a company in New Zealand, launched one of their rockets and sent a bunch of satellites up for the US military and NASA and some other universities. Throughout 2020, SpaceX will send up many more of their Starlink satellites that are going to provide internet on a global level. On the government side, the UAE is getting into the game, and this is kind of amazing because they went from having basically nothing to getting a spacecraft that they're flying to the moon. It's all home built, it's all their own systems, and they're flying directly to Mars. They've not even bothered to try to go to the moon. They're directly going to Mars, and they're launching on the 14th of July. And on the 17th of July, NASA is going to launch its Mars 2020 mission to actually go and generate oxygen on the surface of Mars. Now, you might wonder why these are so closely packed together. The Earth the Earth goes around the sun, and Mars also goes around the sun, right? And the two of them line up very perfectly every 2 years so that the flight distance between us and Mars is the shortest. And that to be able to meet that shortest distance for an arrival time, you could have to launch in July. There are just a few days where you can actually do this. So every 2 years, if you pay attention, in around July sometime, what you'll find is a bunch of missions being sent off to Mars by different entities at the same time. And in late 2020, China's going to land its Chang'e 5 mission, and they're going for a lunar sample return, which I think will be very interesting. All right, so let's talk about the first commercial launch to the International Space Station, which was on the May 30th. And this is the whole reason that we are doing this webinar, because I really want to talk about how astronauts spend their time up there. So they flew up on the 30th, and it took them 19 hours to get to the International Space Station. They don't just go at a direct path, they have to do some orbits and just meet up. And what are they doing up there? Right now, they're looking at proof of technology. You know, we are talking about lunar and Mars colonies. It's not as far away as people used to say. You need to know how humans will survive in space. So the primary task of every astronaut that goes up there is to serve as a human laboratory experiment. Their heart rates, their breathing, their blood, everything is constantly monitored and sampled so that we can better understand how those people do. The one issue I take with that is they are measuring people who have perfect health. Now, if you really do want to build on the moon and Mars, you're going to have to develop a workforce to go up there. That's going to be, you know, your average citizen. So somebody's going to have to come up with medical protocols for how pharmaceuticals work in space, for example. So if you have a middle-aged mom like me that goes up, how will I be affected by outer space? I don't run marathons, and while I'd like to think I'm in reasonably good shape, I'm certainly not as fit as an astronaut. So we need to know how your average person would do up there, and there's just a wealth of data already available. It's publicly available because it comes not just from NASA, but the European Space Agency and the Japanese. And if anybody wants to put that together as a project from a medical perspective, I think the first person that has that protocol ready when space tourism comes into place is going to actually be at the right place at the right time. So what else? Oh, the proof of technology. One of the things that I think is really cool is the astronauts talked about the difference between going up on the space shuttle versus going up with SpaceX. And a couple of these guys that went up had gone up earlier on the shuttle, and they said that it was a much smoother ride with these new engines. Parts of these engines are 3D printed, and they use a different fuel, and that's part of the reason, but you know, they're already seeing a difference, which I think is pretty fun. And then finally, they do a lot of experiments up there on the space station, not just with their own bodies, but with the kits that the students sent up and some other interesting things. Okay, so why outer space? Let me offer you the third poll here. Now, this is a question that I like to ask whenever I give a talk in person. Have you ever wanted to be an astronaut? So what often happens is one person will shyly look around and raise their hand, and as soon as they raise their hand, somebody else raises their hand, and pretty soon you've got like half the audience raising their hand. So we've all had this sort of secret dream to be an astronaut. And I mean, I get that. My plan is to take my husband to outer space for our 50th wedding anniversary. And I'm not kidding about this. I think by that point, the price of an airplane ticket to, I guess, a trip to space will be about the same as a first class plane ride. And we're coming up on 30 years now. So another 20 years, I think we'll get there. I think at that point, he and I are going to take our vacation for our 50th wedding anniversary in outer space. All right, so it looks like we have a minute worth of time here for you guys. Let's end the poll and let me share the results with you. All right, have you ever wanted to be an astronaut? Yes, it was a childhood dream, about 30% of you. Yes, it's a dream of mine, 44%. Somebody out there is afraid of heights. That's cute. And there are some of you who have not given this much thought, about a quarter of you. So hopefully after this, those of you who haven't given this much thought will actually make some further considerations and just look at the feasibility and the reality of what we're talking about here in terms of space. So, and the person that's afraid of heights, I'm sorry. Okay. All right, so let's talk a little bit about the commercial applications in space. And this is where the real opportunities for you guys come in, and this is where the real benefits to planet Earth show up. All of these experiments that people are talking about up there, actually, this here is one of these astronauts who, by the way, I think totally looks like Jean-Luc Picard. This particular guy here is plugging in a little sensor system on the space station from the European Space Agency. And here is another astronaut holding a component. It's actually floating in the individual's fingers here. I don't know, it looks like a man's arm. It's actually floating in space. This is a 3D printer over here. And what he's doing is he is 3D printing this particular wrench in space. Now, without gravity, the way that 3D printing works is very different from what you have here on Earth, because on Earth, they just lay down a layer of material, printer goes back and forth, laying down, it's additive manufacturing, right? Layer after layer after layer. When you don't have gravity, what you have to do is rely on the ability of the material to hold itself together, and that changes a lot of things. Now, why is 3D printing interesting? So when you do go to Mars or the Moon, for example, you're not going to be able to carry everything with you that you're ever going to need. You're going to have to be able to build locally. And that's one of the reasons that they're testing this out. The other thing is, when you want to build like a really flimsy, like a tenuous object with very thin structures, for example, you can't do that here on Earth because it will collapse. So you could start building something like that in outer space and then bring it back down to Earth for the remaining manufacturing. Another thing that they're doing in space right now is they're looking at bioprinting organs. They're actually bioprinting tissue up there. And the uses of that are obvious, right? If people are on some of these long journeys and they have a medical emergency and they need something, they're going to have to be able to print it. And in the case of people here on Earth, bioprinting is interesting because we may at some point not have to wait for donations of hearts or livers, other organs for people. There will not have to be a standby list where you sadly have to wait for somebody else to die to get an organ. They'll just be able to print one for you that will actually be biocompatible also. So in terms of human health, looking at future settlements on Moon and Mars, I think, is the driving motivation. And then agriculture is also important. If you've ever watched any of these science fiction movies, you know that they're very much into growing potatoes and whatnot. Hydroponics is also an interesting area in space. So what else? So what about some applications in space that we have already in our hands? What you see here is this material, this gold material, which is actually a thermal space blanket. It's a material that's used to moderate the temperature fluctuations on spacecraft. This is the Herschel Space Observatory. I worked on this mission back in the late 2000s. And this same material, somebody figured out that you could commercialize this and started selling it. I just went on Amazon. You can buy one of these blankets here for $1.69, which is incredible. And if you ever have bought one of these, you can get them at camping stores, for instance. They are like basically thinner than paper. They feel like nothing, but if you put your hand inside of it, you can feel the heat radiating off the back of your hand. They're just so efficient. The reason I like to use this example is it's a perfect example of stuff that's been built for space specifically that people down on Earth have thought about applying to meet immediate human needs. And if you've ever seen images of refugee camps, for example, a lot of the people are covering themselves with these thin space blankets. So what about pharmaceuticals? One of the things that you can do in space is test bone loss medications. So astronauts who are up there don't have any pull on their body weight, right? There's no gravity, so they actually start to lose bone mass very quickly. It's a problem that's similar to what the elderly face here on Earth. And so there was for a long time thoughts about how can we address both populations at the same time. And this company called Amgen actually developed a drug called Prolia, which has done incredibly well. So they did last year in the fourth quarter, they did about 500 million in sales, right? So you think about that per year, that's $2 billion they're making on this medication. And this is a mouse that they sent up to space. What they did was they injected 2 groups of mice with this drug on the Earth as a control, and they sent these guys up there. You can see it's floating around. It's actually a funny, if you can go look on YouTube, it's kind of funny watching this guy scramble around. But because he was in space and there was no load on his bones, this mouse lost bone mass very quickly. And so the clinical trial to test the effects of the Prolia was much more rapid. The turnaround was much quicker than what you would have gotten if you'd done this on Earth. So yeah, for them, even 3 months, $500 million, I think they benefited from that greatly. Another thing that you can do is you can look at bone loss, bacteria growth, like our students with the brother with the 2 teeth looked at. Now the student experiments, of course, are done by students, and I should say they are not scientifically rigorous. So while they can get some data, it wouldn't be something that we would immediately want to put into publications, but the whole point here is to get them to learn how to do this stuff. So whether they go into space or any other sector, they'll have these amazing skills that they can apply. So with regard to pharmaceuticals, there's an experiment that's going on right now that is built upon some very interesting work that was done about 5 years ago. So when you talk about protein crystals and you build them on Earth, they look something like this. This is your left-hand side picture here. You can see that you get these structures. This is, on a microscopic level. You can get these structures that are fairly jumbled and very short. If you take the same material into space, what you get is a much more sturdy, bigger pieces within the structure, and there's much more space in between the different components. And so that makes it a lot easier in space once you build these things to actually be able to study them using X-rays. So they have instrumentation on board where you build the crystals and then you study their structure and you understand a little bit more about how they interact with other compounds. And this helps you to develop experimental drugs. So our students in 2019 sent up a crystallization experiment themselves. So they had a solution and they had some material that once they got to space, they wrote some software that as soon as the astronauts plugged it in and it had power, after a certain period of time, the 2 materials flew in together and they took some pictures to see how quickly the crystallization would happen. So this was something that was done in 2015, and we found that the structure is much cleaner and much sturdier when you build it in space without the pull of gravity to cause all this jumbling. And so Dover Life Sciences, just this time around, sent up some protein crystals to treat that they're trying to use for medication to treat metabolic disorders such as diabetes. What they're going to do is study the structure in these particular kinds of crystals and see how they interact by themselves or with other molecules. And not only are they thinking that they can block metabolic processes such as diabetes, if they can alter metabolism, then there could potentially also be applications for the treatment of cancer. There is another company that's going up called CamMed. This here is an insulin delivery patch. It's very thin, you can tell by the guy's hand, and it's very small. And what they're trying to do is test it up in space. And so why do that in space? When you have a very fragile system and you've got surface tension and you've got gravity and you've got all kinds of factors that are affecting it, if you can pull one of those out of the equation, it's just like if your phone won't turn on, you press the button and you look at the cable, and then you sort of do a process of elimination to see what's really going on. In this case, what you would do is remove gravity from the equation and then actually see what is happening in terms of this drug delivery patch that these guys are coming up with. It's called Evo Pump. So looks like we're coming up on 8 o'clock. I'll be quick with the rest of these here. So in terms of the government and the space sector, NASA actually has inventions that they've patented where they want people to come in and commercialize those inventions. You do have to have a US-based entity for this, but if anybody seriously wants to talk about this, we can figure out how to make this happen. And on the commercial side, space investments, we have had of $5.4 billion in investments as of, this was last year, and $109 billion to date. Most of that goes to big companies like SpaceX, but we've had 822 companies that have actually gotten investments in the, on the commercial side. So this is a map from this database called NewSpaceHub.co. You can go and look at that. I'll actually provide you with a discount code if you want to subscribe to them. They're pretty cool. But I just did a download a couple weeks ago, on about a month ago, I guess, on how many startups there are in the world right now in the space sector. And you can see they're in everything from additive manufacturing, which we discussed before, cybersecurity, robotics, space tourism, weather. These companies are working all across the board. And actually, if you do want a subscription, just use this link here. I'm going to send this all to you later when we have the follow-up email that goes out, and you can get a 15% discount for getting in here. And I use this database all the time because if I want to know, okay, who's working on CubeSats right now, on CubeSat propulsion, or who's working in education right now, and I just want to find somebody to talk to bounce some ideas off of, this database is fairly current, and I think it's a really cool resource. All right, now I want to talk about you. So NewSpace needs your expertise. One of the reasons that I asked you guys to do the registration and answer the questionnaires on Google was I really wanted to see where your interests lie and what your focus is. So you were asked, what is your level of engagement in the space sector? And the majority of you are astro-curious, which means you're newcomers. So I hope that this makes you into people that keep coming back for more and more. We had some people that have some knowledge of space, and then others who have worked in the sector, and then others who, I think we had, I think one astronaut. I'm not really sure about that. Although we do have astronauts we work with. I didn't see an email from somebody I recognized. And so most of the majority of you guys, I think, are just coming into this as newbies. And then what I wanted to know too was how diverse is your background, and what do you guys really know? What are you bringing to the table here? And the majority of you guys are in engineering and space, not engineering and science, not space related. And then we have some people here who are space related. So this is a big chunk. And then business and marketing is about 10%, and education is about 9%. And in terms of finance, I do know I recognize some of the emails. I know there are some of you investors out there who are putting down your fields of interest rather than actually the fact that you are in finance. So I welcome all of you guys. I'm really glad you're here. And I just wanted to go deep a little bit into what it is that you might want to consider in terms of your future in space. So, in business and marketing and media communications, legal, and in finance, what you do for any other sector is exactly what you would want to do for the space sector. Now that you're convinced that rocket science isn't hard, it's not an industry that you need to stay away from, we would very much need you to help us with sector growth and customer acquisition. If you're in media and communication, part of your job is to get consumer buy-in, but the other part of your job is a super easy sell because everybody loves space. I can't tell you how many people talked to me about the SpaceX launch the other day. So, that part of it, I think getting people inspired would be pretty easy for you. Legal, property rights, UN cooperative treaties, how do we enforce those? Who does what? We already talked about the shooting down your own satellite as an example earlier. There's a lot of work to be done there. Financing, that's always the issue, isn't it, for startups? We need your funding to get this going on a global level. And people who are getting sort of risk averse right now because of COVID, I'm hoping we'll look at the bigger term picture here and see all of these opportunities that are coming up where if you're the first one on board, you're going to actually do some really good stuff and come out very well. So what about the other areas I asked about in the survey? Medicine and biological sciences, social services, and then engineering space and engineering not space. Pharmaceuticals and space tourism, we've gone into a little bit of that. We need experts to really help with that. And we talked about somebody having a medical protocol ready for space tourism. That would be super. Social services, applying space technology for the greater good. You know, we talk about isolation right now. All of us are just feeling sort of, you know, cut off from the rest of the world. What kind of management tools, what kind of apps or software services can we provide to help people in space who are isolated and apply those same things to people down here on Earth? In terms of engineering that's not space related or science, there's a lot of transferable technology out there. There are a lot of things that you already do for Earth that can be done in space. So for instance, I talked to a team in Singapore that was building soil sensors for vertical gardens, because, you know, on all the buildings, on all the high rises, sometimes you've got plants and stuff on the outside, and it's just not possible to water them if it's not raining or to just check on them. But if you are able to put some remote sensors in there and use some smart AI to figure out what is the pH, what is the watering, and just take care of those remotely, that's a net technology that you can apply on Earth and also apply it to space. So, you know, whenever we're sending off, you know, something for crop monitoring, or even you can translate those sensors into something that checks the spacecraft itself in a sort of cohesive, intelligent way and takes decisions. And of course, if you're in the space sector, if you're a space nerd like me, we just hope that you continue to push boundaries. All right, so we have just a couple more slides. How can you get involved? So this is a workshop that you guys have attended. I'm hoping that you guys end up coming back for more. We have a 90-minute workshop, an interactive workshop on the 30th of June. So that's in 2 weeks, where we'll go over the status of NewSpace. And we're going to have an industry expert talking to you, just like we did last time. This guy's name is Twyman Clements. He's CEO of a company called Space Tango. Space Tango actually sends payloads to space. They particularly work on the biological side, but they also work with experiments that go up either for students or on the commercial side, helping you develop sensors and taking what you've got that works on the ground and translating it into something that could handle the environment of space. And they'll ship you off to the International Space Station to either be inside with the astronauts where the biological stuff is, or if you want to be out in hard space, they'll work with you on that as well. So he has some really cool stuff he's going to talk to us about that they're working on right now. And after we do that, we will do an overview of selected space companies. So we pick a couple companies each time, and we do breakout sessions in Zoom of small groups where you're led by one of our team members to go through this analysis of the business case for particular companies. Last time we did SpaceX, and we also did Spire. And the reports that you put together actually are online. So if you go to this link right here, AstroHub Masterclasses, if you go to the website, you will see the report that we put out from the last time. And this is something you should feel free to put onto your LinkedIn. And I think it shows that you've actually gone and done something in the space sector. You're not just sitting there Googling a bunch of information, and you're getting some solid exposure here from people who are already involved in the sector. And so for the next 24 hours, we are offering a discount code of 30%. Use ISS 30, no spaces in there. So for the next 24 hours, if you do want to go and sign up, you can sign up for US $70 rather than the usual price of $99. And so this toolkit here, that just to finish up with this, the in-depth case studies. So there are 20 people per class. And we have a testimonial here from Avinash, who was on last time. I don't know if he's on again this time. This is actually a repository that I consider to be a public resource for the NewSpace community. So this is one of the ways that we want to make sure that we're providing what we learned to everybody else. So here are some more things that you might want to consider. You can go look at our free webinars from earlier. You've got today's, and then you've got the one that was done on the 12th of May, which is more of an overview of commercial space. And then we've got the case studies that we've done in the past that you can look at. And in addition to these links from us, there's some other really interesting places you can look, of course. NewSpaceHub.co is a good one if you want to know about startups. And if you want to know about funding of companies, of course, some of you may already be familiar with Crunchbase and Owler. Space Capital is a good, they're a VC that does a lot of investments in space. They're a good place to go. They have a good series of reports you might want to look at. And then I think this particular article here from Morgan Stanley on how to invest in space, it is 3 years old, but it does a really good synopsis of what's going on and what the future trends will be. This article from last year, Space Flight Year in Review, I think is pretty informative as well. So I think I'm going to leave it at that. I've gone over by about 7 minutes here. I do apologize for that. I think at this point we'll leave this up, and I might switch over to taking some questions. There are some coming through here. Please do type your questions into the chat, and what I will do is scroll through these and just answer a few as we go along. Aditya is asking, are these more potential applications, crop readiness, predicting forest fires, etc., or are they already in widespread use? If not, what do you see as the reason for the lack in widespread adoption? These are already being used to some degree. You've got not just the tech issue here, but you have the social issue too, right? So what you need to do is take this data and go to some small farmer somewhere and say, yes, it's worthwhile for you to subscribe to our data service, right? And that's where the business people come in. There's a company called SatSure that is based out of Europe. They're actually from India originally, but they're in Europe now. And they're providing insurance, crop insurance, it's for insurance companies. They're providing data to help them reduce the risk when it comes to their crop insurance. And as far as predicting forest fires, that's happening as well. A cool example with natural disasters, since you asked, was when they had those earthquakes in Nepal a few years ago, they were able to use satellite images to identify isolated villages and then use airplanes to send in emergency supplies. So this is something where you couldn't just, space data by itself would not have done much. You also had to have people on the ground working together, interpreting that data to provide important rescue services, social services. Another question, what do you think is a formal degree needed for a student to get involved in space science and tech, or can even a dropout do so? I guess that's the Mark Zuckerberg question, isn't it? It really depends on your energy level and what you think you can contribute. And if you don't have a technical degree, but you have another interest, like let's say you've run a bunch of businesses, but you haven't gone to college, I'm open to it. See, the thing is, the whole sector right now is wide open, right? We basically are living in a very open time. And since nobody has set any constraints or limitations on the commercial space sector yet, if you come in and you decide to do something, you will actually be defining the direction that particular service goes, and everybody's going to be following you. So if you think you can do it, if you think you can put together a team to do something effectively, I think that the degree that you have is a secondary concern. But I don't want anybody to go and tell their parents, I said, don't go to college. So the answer is, stick to what you know and what you're passionate about, and I'm sure you will succeed. All right, so here's a fun, idealistic futuristic question from an astro-curious person, Tarunya. What do you personally think of the future of humanity as an interstellar species? And what would the roadmap be to colonizing space? I'll take the second one first because it's easier. So I think within the next 10 years, probably even 5 years, we're going to have space tourism. I have an article posted on LinkedIn about this where I did an analysis of my grandniece and what life will be like for her when she gets to be 40 years old. I think she will be one of those people that will be able to go to space. I'm going to send you guys a link to that. It's kind of fun to look at. So I think the first step will be space tourism, where you go up there and you spend, maybe like an hour floating around in micro G. Then after that, people will go to the moon. And then after that, people will go to Mars. The real question here is commercial viability. And that's something that the technologists really can't work on. This is where the value of the service and its importance to society has to be conveyed by people who are not building the software and the hardware. So beyond that, I'm not really sure what I can say. And in terms of an interstellar species, that would be cool. I don't have a timetable for that just because of the sheer distance, right? I mean, the nearest star is 4 light years away. That's, traveling at the speed of light for 4 years. That's cool. I don't know, but it's fun to think about. So then Ian Solomon said that you noticed on our map that Africa is not involved much. There are people who are interested. Have we reached out? We have some people that, you know, come and talk to us, but I think again here, the issue for people is funding. You can have a great idea, but you actually need to be able to test it. And you need to have somebody fund you to put stuff together. And my own take on space tech, if you're running a startup, is you have to fly it before you get too far. You have to send some kind of prototype up to the International Space Station, whether you put it inside or outside, or put it on a CubeSat. You have to have your technology or your service actually in space to make sure it works, because I've seen too many experiments that sit on a lab bench just looking, you know, really pretty and glamorous. But when they're sent up, you know, things go awry. Space is a complete game changer. Every mission I've ever worked on has had, you know, significant differences in instrument performance when you get up there. So the earlier you fly, the better off you are. And now that they are opening up commercial pathways to doing this on the space station, I'm really hoping that we get some investors on board who see the value of this and step up and help people, not just in Africa, but everybody else. Is there any other question here? Okay, specified cases, Abhilasha says, for software, space software solutions. That's a very broad question. I'm not sure if you're talking about spacecraft operations. There are solutions you can provide for that based on AI. That's one thing you can do. And then actually, if you want to take data from space and do data analytics on that, that actually is something investors are very interested in right now, is taking the infrastructure that's already up there and using it to build new kinds of data for people here on Earth to supplement whatever we're getting, you know, on our phones or whatever else we're doing right now. Right, let's see. What else have we got here? Scrolling through. So Guru is asking, does AstroHub plan on making more than CubeSats? Actually, what's interesting is at this moment, we are not even able to make our CubeSats because our supply chain from China has been cut off. But down the road, are we open? Yes, we most definitely are. The field is changing very quickly. So if you have any ideas on where there might be a sweet spot, just go ahead and message me and we can talk further. When do I think mass production in microgravity will become feasible and economical? Mass production of what? I guess that's the question. Once we have an economy up there, once we have enough spacecraft up there just for industrial purposes, it will no longer make sense to send up every little bit of something that we need, and it will make more sense to be able to produce up there. But you're also going to need a source of material, right? So I think initially we'll just start sending up the material, like for instance, to 3D print. We'll send that material up, but eventually we're going to have to start using local resources from the moon and asteroids and so on. Okay, so if anybody doesn't have any more questions at the moment, it looks like we're a little bit over. So thank you very much for your time. I hope you do sign up for that workshop that we have in a couple weeks, the master class. That discount's going to be there for another 24 hours. So let me know if you have any questions. And thank you very much for your time, you guys. Really appreciated it. Have a good day or good night.